Now let's deal with acidoses and alkaloses and how we deal with pH in the body. The plasma pH, or what I'm going to call the extracellular fluid pH, is 7.4. But how do you get this 7.4 value? Because again, it's just an aggregate of all the acids produced throughout the body, and then all the acids that you've gotten rid of, and all the acids you've buffered. So let's go through one by one where these come from, and then deal with what happens to them. The biggest thing is metabolism. During metabolism, you create acids. Most of the acids you produce are volatile or from CO2. So in this case, about 15,000 millimoles of acid is produced per day by carbon dioxide. This is your volatile acid. This is a huge amount of acid through aerobic metabolism. What do I mean by aerobic metabolism? Remember, when you go through glycolysis into the pyruvate dehydrogenase complex, through the Krebs cycle and then the electron transport chain, there were CO2s that were kicked off along the way as you produced ATP. Interestingly, there is also a little bit of acid that's produced from non-volatile acids. Only about 40 millimole. So if you think about this, 15,000 volatile, 40 millimole were the non-volatile. What do you do with these volatile acids? It's very easy. You just take CO2 to the lungs and you breathe it out. And that 15,000 millimoles, gone. You don't have to deal with it anymore. Simply by breathing out, you've gotten rid of almost all of your acid. You can't, though, breathe off that 40 millimole. Well, these non-volatile acids will not be able to produce CO2, go to the lungs, and get breathed off. You have to do something else with them. Okay, let's talk through how else we can get acid. You have a little bit of exchange of acids and bases in your GI tract. So maybe about 30 millimole per day of acid comes from the gut. You combine that with the 40 millimole that's produced during anaerobic metabolism. And that gives you a sum total of around 70 millimole. You have to deal with that 70 millimole. The only organ system you have to deal with the 70 millimole is the kidneys. You have to work through what to do with that. The kidneys do two things for you. One is it reabsorbs bicarb. Remember, bicarb is our primary buffer in the extracellular fluid. So you can see a filtered load of bicarb might be somewhere around 4,220 amount of bicarb filtered per day. You reabsorb all of it during the course of the day so you don't lose bicarb. You don't want to lose your buffer. Keep the buffers around. But now you still have this 70 millimole. You have to do something with that. It just so happens that as you buffer the 70 millimole of hydrogen ions, you produce 70 millimole of new bicarb. So every time you get rid of a hydrogen ion and you urinate it out, you make a new bicarb. So this is what we're going to deal with today, is how the kidneys deal with those 70 millimole of non-volatile acids. But let's also revisit how this process works. As you put all the pieces together, know that the GI system is involved, but it gives you only a minor amount of the non-volatile acids. Metabolism gives you the most non-volatile acids. And then the 15,000 millimoles of volatile acid, the lungs just take care of. So we don't have to deal with that in a great extent because it's so much is being taken care of from the respiratory system. You urinate out 70 millimoles of hydrogen ions, which is the sum total from metabolism and the gut. When thinking about non-volatile acids, Let's revisit how the body typically deals with acid. It handles these non-volatile acids at the level of the kidney. So we need to talk through the kidney-specific mechanisms by which it deals with these non-volatile acids. So the kidney's doing two things for us: reabsorbing bicarb and making new bicarb while it's kicking out an acid, non-volatile acid.